All right. On our warm-up, we were supposed to take the steps that they gave us and put them in order so that we could prove the sum of any two consecutive integers is an odd number. Of these 4 steps, which one do you think would have to be the first statement and reason? Close. There's something that has to come before that. We're trying to prove that the sum of any two consecutive integers is an odd number, so the first thing I need to do is talk about what consecutive integers are, right? So which one of these steps is establishing what we're going to use to represent these consecutive integers? 2. 2 would be our first step because it's defining that we're going to use n and n plus 1 to mean our two consecutive integers. So step 2 would be my first one. If I know that n and n plus 1 are my consecutive integers, what do I want to do with those? I want to make an equation, so that would be step number 4. So we made an equation, n plus 1. Here's my two consecutive integers. And if I combine the like terms, that gives me 2n plus 1. When I take 2 and I multiply it by a number, I always end up with what type of number? An even number. If I take an even number like 8, or 32, or 40, and I add 1 onto it, so 9, 33, 41, 9, 33, 41, when I add 1 to an even number, I always end up with what type of number? An odd number. Is there a step that tells me that? Step number 1. So 2n would be even, which means 2n plus 1 has to be odd. And that came from adding those two consecutive integers together. So what would my last step be then? 3. Because 2n plus 1 is odd, the sum of any two consecutive integers is an odd number. Excuse me. All right. Go ahead and put the warm-up away for now. We'll be collecting those tomorrow. And pull out that new notes packet, the 3-5 notes packet. You have a notes packet, and then you have a homework packet that you picked up. The homework is due on Monday. The notes we're going to do today, and we'll finish up tomorrow. Today, tomorrow, and Monday, we are going to practice writing more proofs. So what we learned how to do, we're going to continue working with those skills. Today and half of tomorrow, we're specifically going to focus on proofs about segments. What should my first statement be on number 1? Segment QT is congruent to segment RV. And why do I know that? Why am I allowed to say that? Given. I'm going to go ahead and mark that on my picture. Here's QT. Here's RV. And we were told that they were congruent. So I'm going to mark them with congruence marks. If I know those segments are congruent, what do I know about their measurements? They're equal. The measurement of segment QT is equal to the measurement of segment RV. If I know they're congruent, why am I allowed to say this? I know two segments are congruent. Why am I allowed to say that means their measurements are the same? What'd you say? Sorry, I can't hear you. My apologies. Close. Definition of congruent segments. All right, so let's see something else that we can say about QT and RV. Here's segment QT. Are there any points in between Q and T? R is between Q and T. So segment QT is made up of two smaller segments put together. What are the two smaller segments that make up segment QT? So the length of segment QR put together with the length of segment RT would give me the length of segment QT. What about if I look at segment RV, this one right here? RT and TV. So segment RV is segment RT plus segment TV, those lengths. Why am I allowed to make that statement? I made both of the statements on the same line, so I'm going to use the same reason for both of these. What allows me to put two smaller segments together to make a bigger segment? Segment addition postulate. All right. So here in number 2, where I had this equality, in the place of the QT, I'm going to put QR plus RT. What could I put in the place of the RV? What is the same size as RV? RT plus TV. When I replace things with something else of equal value, what am I using? Substitution property. Do you guys notice anything about that equation that we wrote in step 4? Something that's the same on both sides? RT is the same on both sides. What is it that I'm trying to prove again? What is it that I'm trying to prove? What am I trying to get to? I want to make a relationship between QR and TV here. I almost have it, except each side has this RT. Am I allowed to subtract something from one side as long as I subtract the same thing from the other side? What property lets me do that? Subtraction property of equality. So I would have QR is equal to TV. I'm going to subtract RT from both sides using the subtraction property of equality. I'm almost there. Is this exactly what I was asked to prove? No. What was I asked to show in the end? That they're congruent. That segment QR is congruent to segment TV. If I know two segments have the same measurements, they're the same length as each other, why am I allowed to then say that means they have to be congruent? Yes. The same thing that allowed me to say right here, if two segments are congruent, then I know their measurements are equal. If I know their measurements are equal, then I know they're congruent. That would be the definition of congruent segments. Nicely done. All right. Get away from me, dear. Let's go look at the next one. Where do I want to start on this? I want to start with my given. R is the midpoint of QS. Is there anything else that was given? T is the midpoint of VS. Anything else? Segment QR is congruent to segment VT. We need to rewrite all of those in this first statement box. It is really important that you write them down here. Don't just draw an arrow to the box, because we want to be able to see exactly what we're doing and why. So R is the midpoint of segment QS. T is the midpoint of segment VS. And then segment QR is congruent to segment VT. And why am I allowed to make all three of those statements? Because it was given to us. I want to point something out real quick because this does become important later on. I wrote all three of those things in the same box because they were all my given information, so I'm using the same reason for all three of those statements. That's what allows me to put them in the same box together. I could have written it down, each piece of information in its own box, and my reason for each of those would be given, and then given, and then given. So you can take up more lines to say the same thing, or you can do it all in one if your reason is the same. If the reason is the same, then you can combine pieces into statements. All right, so here's R. It says it's the midpoint of QS. So what do I know about those two smaller segments there? They're congruent, which means what about their lengths? They're the same. They're equal. So QR has the same length as RS. So I'm using this piece of given information. What would allow me to make that statement? If I know R is the midpoint of QS, what is it that allows me to say they have the same measurements? Not definition of congruent segments, because they didn't tell me they were congruent. They just told me what the midpoint was. Definition of midpoint. Did they tell me about the midpoint of anything else? T is the midpoint of VS. So could I make a similar statement using the same reason about segments over here? Yes. Which segments would I know are the same size? VT and TS. Segment VT is the same measurement as segment TS. Same reason, definition of midpoint. Then I want to use this last piece of given information. Is that telling me about a midpoint? Segment QR is congruent to segment VT. Does it tell me anything about a midpoint there? No. Then I can't use definition of midpoint as my reason, so it's going to need to go on a new line by itself. If I know that QR, this one right here, and VT are the same size, what does that mean about their measurements? They're equal. So segment QR, its measurement is the same as VT. What am I using there? Because they didn't tell me about midpoint, so I can't use definition of midpoint again. Definition of congruent segments. What are we supposed to prove again? Segment RS is congruent to segment TS. Is there any way that I can make a relationship between QR and the RS that I have here? QR, I can replace with RS because I was told that they were the same size, because R is the midpoint. That meant I knew they were the same size. Can I do a similar kind of replacement with VT? Yes, I know that VT is the same size as what? TS. When I replace things with something else of equal value, I'm using substitution. Substitution property, sorry, not property of equality, just substitution property. My bad. Is that what I was asked to prove, that RS is equal to TS? I was asked to show what about them? They're congruent. Segment RS is congruent to segment TS. Well, I know they're the same size. That's what we had in step 4. We had that their measurements are equal. Why am I allowed to then take that a step further and say that means they have to be congruent? Definition of congruent segments. Quick question before we go look at number 3. Am I allowed to reuse the same reason in a proof? Yes. If I use the same reasoning, then I can use the same reason. If I know two segments are congruent, then I know their measurements are equal. That's definition of congruent segments. If I know two segments' measurements are equal, then I know those two segments are congruent. That would also be definition of congruent segments. All right, let's flip it over and look at number 3. What should go in this very top box? Segment CE is congruent to segment FE. Segment ED is congruent to segment EG. And why am I allowed to say that? Because that was given. If CE is congruent to FE, then what do I know about their measurements? That they are equal. So the length of segment CE is equal to the length of segment FE. Similarly, if I know that segment ED and EG are congruent, what do I know about their measurements? They are equal. So ED is equal to EG. I'm using the same reasoning for both of these. Why am I allowed to say if I know they're congruent, then that means the segments are equal? Definition of congruent segments. All right, I'm going to stop for just a moment and mark up on this picture what we've got. We have that CE, this little segment here, is the same size as FE, this one here. And then I have that ED, this bigger one down here, is the same size as EG. So far, so good? So somehow, I have to get here. Where's segment CD in the picture? That's this whole line segment here. Where's FG? It's this whole line segment here. So somehow I'm going to have to put CE and ED together so that I get this line segment CD. And I'm going to have to put FE and EG together. Well, I think I can do this. Segment CD is made up of what two smaller segments? CE together with ED. What about for segment FG? FE plus EG. What allows me to say that? Why am I allowed to say that segment CD is these two smaller segments put together? That segment FG is these two smaller segments put together? Segment addition postulate. Okay. So somehow I'm going to have to use the information that I have up here to get to these places. Let's see what I can do. Here I have CE. Here I have CE. Here I have FE, and down here I have FE. And I know that CE and FE are equal. So CE, I'm going to leave a blank, is equal to FE. So far, so good? This is exactly what I have written up here. CE is equal to FE, except I left this blank. I left this gap. Am I allowed to add something to both sides of an equal sign as long as it's the same? What property would I be using if I add the same thing to both sides? If I add the same thing to both sides, like if I add 7 to both sides. Addition property of equality. So I want to add the same thing to both sides here. We're going to use our addition property of equality. All right, so now to decide what to add to both sides. Well, CD is equal to CE plus ED, right? Do you guys agree with that? So I'm going to add ED to this side. Because when I add ED to this side, that makes this equal to CD. But my addition property of equality says that if I add something to one side, I have to add the exact same thing to the other side. So I would have to add ED over here too. That helps me get here, but this side over here isn't this. I have FE, but I don't have EG. What is EG the same size as? EG is the same size as ED. So I can replace ED with EG. What property are we using if we replace something that has equal value? Substitution. Do we know something that is the same size as CE plus ED? What is the same size as CE plus ED? CD. Do I know something that's the same size as FE plus EG? FG. We just did replacements of equal value, so what did I just use? Substitution again. All right, so I have CD is equal to FG. What were we supposed to prove? CD is congruent to FG. Well, if I know those two segments are the same lengths, they have the same measurement, why am I allowed to say that that means those segments are congruent? Definition of congruent segments. Very nice work today. That new homework that you picked up is due on Monday. Our test is a week from today. It is next Thursday. Tomorrow we're going to finish up these notes and we will start on the next set of notes. So you guys will pick those up tomorrow as well. It's going to be more proofs. We're talking about angle relationships. So we'll finish up segments tomorrow and we'll start in on angles. We'll finish up angles on Monday. And then we'll review on Tuesday and Wednesday for your test on Thursday. I hope you guys have a fantastic rest of your day.